Dear students, this is our third class on the chapter Laplace Transform, and today, or in this class, we will solve some problems regarding Laplace Transform, and very often we will use the properties of Laplace Transform as well as some Laplace Transform of some functions to solve these problems. And let us start this class. First one is here, the problem is here. Find the Laplace transform of the following functions. First one is if t is equal to t. Number two is function of t is equal to t to the power n, where n is equal to 1, 2, etc. So here is the first one, that is the Laplace transform of ft, that is equal to t. And now we know that from the definition of a Laplace transform of a function ft, that can be written as or given by L of ft, that is equal to 0 to infinity, then e to the minus pt, then that function ft dt, that is equal to 0 to infinity, and in our present case the function ft is equal to t, and then dt, then dt. Okay, and this this integral can be evaluated by using integration by parts, this method. So that method, in that method you have to take t as constant term, and first, then that is here, and then integrate this term e to the minus pt, that will provide you e to the pt, e to the minus pt by minus p, and the limits are here 0 to infinity. Then minus sign will appear here, and and integration 0 to infinity, the limits are here. Then you have to differentiate this t, that is 1, and integrate this, that is e to the minus pt by minus p, and then dt. So you are familiar with this process, and you know to solve or to evaluate this the value of this type of integral. Okay, so then from here, if you use the limit infinity, then e to the minus pt, this term will give 0 or null result, and when we will use the limit of t as 0, then this term will give you 0. So ultimately this term is nothing but a null or 0. Then just integrate this term. So this minus and this minus will give you a positive or plus sign, but furthermore you have to integrate this e to the power minus pt, that will give you minus of e to the power minus pt by minus of e to the power minus pt by p. You can write it. And then this p and the previous p, that will give you p square, and another negative sign is here, then 0 to infinity. And if you use this limit, then this will give you null result, and if you use this 0 result, then it will give you 1 by p square from here, where p greater than 0. So the Laplace transform of the function ft, that is equal to t, is lt, that is equal to 1 by p square. This is the value of the Laplace transform of the function t, ft, that is equal to t. Now for the function ft, that is equal to t to the power n. So in this case, the function is written here, and now the Laplace transform, you know, the Laplace transform of the function ft, that can be written as ft, that is equal to L of t to the power n, that means 0 to infinity to the minus pt, t to the power n dt. So you have to integrate this by using method of integration by parts. So that is here done here, that is done here, that is first t to the power n is constant, then integrate this term, that is e to the minus pt by minus p, 0 to infinity, limits are here. Then minus 0 to infinity, the integration is there. Then integrate, differentiate this term, that is n, t to the power n minus 1. Then integrate this term, e to the minus pt by minus p, and then dt is here. So that is equal to, from here, you know this term, you know this term, when t is infinity, then this, due to this term, this will give you 0 result, and when t is equal to 0, then this term will give you 0 result. So this is ultimately actually 0. So then from this term, then from here you can write this n and this minus p and this minus p will provide you positive sign. So n by p is here, then 0 to infinity, the rest terms are e to the minus pt, and then t to the power n minus 1 dt. So now to evaluate this, that is equal to this n by p is here, and then take t to the power n minus 1 as constant, that is here, and integrate this, that is e to the power minus pt by minus p, 0 to infinity, the limits are here, and then this n by p is also here with a negative sign, because according to the formula, then minus n by p, then 0 to infinity, then you have to differentiate this term. This term will give you n minus 1 t to the power n minus 2. That is here n minus 1 t to the n minus 2, and differentiate integration of this term, that is minus pt e to the minus pt by minus p. So that is equal to n into n minus 1 from here, c from here. Infinity result will t equal to infinity will for t is equal to infinity. This term will give you 0 result, and for t is equal to 0, this term will give you 0 result. That is, this term is actually 0. The rest terms are these due to from these terms. So that is equal to this minus that is equal to n, and then n minus 1 is here, and this p square is here. Then 0 to infinity, that is here, e to the power minus pt, okay, and t to the power n minus 2 dt. So just look at this term and this term. This is the second line, and this is the third line, and the fourth line. What would be the fourth line? That is, see here n into n minus 1. That means n and n is decreased by 1. That is n minus 1. Here see p, here p square. That means p increased by the power of p is increased by 1. Okay. After that 0 to infinity to pt t to the power. See here 0 to infinity to pt t to the power n minus 1. In this case, it was n. Here n is decreased by 1. Here n is decreased by 2. Also, for the next line, n should be decreased by another one. That is another one. So for the next line, that would be this n is here. This n minus 1 is here. Now n should be decreased by another one. That is n minus 2. P is increased by here 1. So here will be increased by another one. That is p to the 3. And then 0 to infinity e to the power minus pt, and t is decreased, the power of t is decreased by 1, then 2, so here will be 3, and dt. You can do it using this kind of in evaluation. So I am not going through this. If you wish, you can. If you wish, then you can check it. Okay, so the next line will be this, and that can be written in this fashion, that is n into n minus 1. So if we proceed in this way, so the last term will be when n for the last term, that is n. So in this way, see here the first term n minus 1, n minus 2 in this way. So this is the third term. This is the third term. In third term, n actually n minus 2. That means n minus 2 minus 1 actually. N plus 1 minus 2. That means the last term will be 1 here. In this way, if you decrease n in this fashion, so when n is equal to the last term, for the last term, that means when n is equal to n, then see here, this is the just before, or the previous term of the last term. That is, in this series, the last term will be, since the last term will be 0 if n is decreased in this way, but since it is just the previous term of the last term, so here the previous term of the last term will be 1. So the last term is 0, since n minus n, that is equal to 0. But here the term before the last term, that means 1. After that 0. So this series will proceed up to 1. Okay. Then here, see here, this is the third line. So p to the power n. So here will be p to the power n, 0 to infinity minus pt, and then n minus 3. That means we have t to the power n minus 1 dt. So that will provide you. This is nothing but n factorial. This is nothing but n factorial. Then p to the power n, 0 to infinity to the power minus pt, and this will be t to the power 0. That means 1 dt. So that is n factorial p n, 0 to infinity to the minus pt, and then dt into 1 into dt. So this, what is that? This is nothing but the Laplace transform of 1. Okay, 0 to infinity to the minus pt, 1 dt. This is nothing but the Laplace transform of 1. So that is here written here, n factorial by p to the power n, L of 1, that is n factorial pn, and you know that Laplace transform of 1 is equal to 1 by p. So that is n factorial by p to the power n plus 1. So Laplace transform of the function t to the power n of the that is equal to n factorial by p to the power n plus 1. Now find the Laplace transform of the following functions: 2 e to the minus 3x minus e to the minus 3x, then another one is e to the power x with sine square x, and e to the power minus 3x cos hyperbolic 2x. So first one is here. The first problem is here, the Laplace transform of the function e to the 2 e to the 3x minus 3 e to the minus 3x is given by L of 2 e to the 3x minus e to the minus 3x. That is good. It can be written as 2 Laplace transform of e to the 3x, then minus Laplace transform of e to the minus 3x. So that is here. That is here. L e to the 3x. This is the usual or usual method is carried out here, and every line, every step are carried out. Just you look at it, and finally you obtained as L e to the minus 3x is equal to 1 by p plus 3. Or you can directly write, since you know that Laplace transform of e to the power ax is equal to 1 by p minus a. So in this case p is equal to 3, so that will give you 1 by p minus 3. This is the directly I am going here, and the entire calculation is also here, so you can follow this or you can write directly from here. Okay, this is the first one, and then therefore similarly Laplace transform of e to the minus 3x, that would give you the result. Since in this case you know a is minus 3, so that will give you 1 by p plus 3, 1 by p plus 3. Therefore the Laplace transform of this term, that is 2 e to the 3x minus e to the minus 3x, that is equal to from here since e to the 3x Laplace transform of e to the 3x is equal to 1 by p minus 3, so this term will give you, or this term will give you 2 by p minus 3, and then this Laplace transform of this term, that is here 1 by p plus 3. Just simplify it, p square minus 9, and from here, so 2p plus 3 is 6, and then minus p plus 3, that is p plus 9 by p square minus 9. So this is the Laplace transform of the function 2 e to the 3x minus e to the minus 3x. Okay, the next one is here. Laplace transform of the function we have to calculate, e to the power x sine square x, and that can be represented as Laplace transform of e to the power x sine square x. Now the Laplace transform, I am just interested to first find out the value of Laplace transform of sine square x, and that is here. So you can write this sine square x as 1 minus cos 2x. You know that with a half multiplication of half. So you can write sine square x is equal to half 1 minus cos x. So Laplace transform of sine square x, that is equal to half Laplace transform of 1 minus cos 2x. That can be written as 1 by half Laplace transform of 1, then half Laplace transform of cos 2x. So that is equal to, you know that Laplace transform of 1 is equal to 1 by p. So this will result in 1 by 2p, and from here half is there, and you know that Laplace transform of cos x is equal to p by p square plus x. So this is calculated at the very beginning of this chapter. Okay, so Laplace transform of cos x is equal to p by p square plus a square. Just substitute the value here, actually here. So that is equal to minus half. This half is here, then p by p square plus 4, because in this case a is equal to 2. So therefore by simplification 2p and p square plus 4 is here. From here p square plus 4, then minus from here p square. So that will provide you that will provide 2p square by 2p into p square plus 4, and this 2 will cancel, and here another p square was there, this p and this p square, and from here 1p, and here this p and 1p from the p square term will cancel. That will provide you finally 2 by, so sorry, it is 4 by 2p into p square by 4, p square plus 4. So 2 will 4, and here 2, that will provide you 2 by p into p square plus 4. So this is the result for the Laplace transform of sine square x, but our function was e to the power x sine square x. So the Laplace transform of e to the power x sine square x, that is equal to you know the first shifting theorem. The first shifting theorem was there, what? L Laplace transform of e to the power x fx, that is equal to Laplace transform of p minus a. That means in case of Laplace transform of the function fx, that is fp, and if it is multiplied by e to the power x, then fp p is replaced, p should be replaced by p minus a. This was the first shifting theorem. You know, we have studied it, we have learned it. So from in our case, see here, a is 1, since it is e to the power x, so a is 1. So in this expression, that means the Laplace transform is of sine square x is this, In this expression, P should be replaced by P minus 1. P minus 1 since A is 1 in this case. So by replacing P by P minus 1 in this expression, we will obtain the value of Laplace transform of e to the power x sin square x. That is equal to here 2, this 2 is there, then P minus 1, then P minus 1 square, then this 4 is here. So that is equal to 2 by P minus 1 is taken as common term 1, that the rest parts are here. No, this is multiplication, so no problem, this is the result. But so therefore you can write the Laplace transform of e to the power x sin square x is equal to this. This is the result. Therefore the Laplace transform of this function of the function e to the power x sin square x is equal to this. Now another one is here, the function fx is equal to e to the power minus 3x plus hyperbolic 2x. We have to compute or calculate the Laplace transform of this function, and before doing that we have to first calculate the Laplace transform of cos hyperbolic 2x. Already we have calculated it, but here we are trying to once again to calculate the value of cos hyperbolic 2x. So that is here, that is equal to L of, you know that cos hyperbolic x can be written as e to the power ax plus e to the power minus ax by 2. That is equal to half L Laplace transform of e to the power x, then plus half Laplace transform of e to the power minus ax. This can be written in this way. So you find, furthermore you know that the Laplace transform e to the power ax is equal to 1 by p minus a. So this term will provide you half, then 1 by p minus a, and this term will provide you plus half. Then since in this case a is minus a, so it would be 1 by p minus of minus a, that means 1 by p plus a. So in our present case, in this case, a is equal to 2. So the Laplace transform of cos hyperbolic 2x, that would be 1 by 2, then p 1 by p minus 2, then plus 1 by p plus 2. This half is taken as constant term. So therefore the Laplace transform of cos hyperbolic 2x is here. Just simplify this. Half is there, then these two, that will provide p square minus 4. Here p plus 2, then plus p minus 2, that is equal to half, then plus 2p by p square minus 4, that is p by p square minus 4. So now we have already calculated the Laplace transform of cos hyperbolic 2x. So the Laplace transform of e to the minus 3x cos hyperbolic 2x, that would be, what would be the value of this term, this Laplace transform. So from the first shifting property, you know that Laplace transform of e to the power ax fx, that is equal to f of p minus a, where you know that f of p is the Laplace transform of this function fx. So in this case, p is replaced by p minus a, but in our present case, you see here a is equal to minus 3. So p should be replaced by p of p minus 3, that means p plus 3. So just replace p by p plus 3 in this expression. That will result in the Laplace transform of this function, that is equal to, so here p is replaced by p plus 3, and here p is also should be replaced by p plus 3, that is p plus 3 whole square minus 4. Just p plus 3 is here, just write it, it can be written as p square plus 6p plus 9, then minus 4, that is equal to p plus 3 by p square plus 6p plus 5. So this is the value of the Laplace transform of e to the minus 3x cos hyperbolic 2x. Next one is here, find the Laplace transform of the function ft, that is equal to 1 by t e to the minus alpha t minus e to the minus beta t. So here the given function is ft is equal to 1 by t e to the minus alpha t minus e to the minus beta t. So the Laplace transform of this function, that is L of ft, that is equal to L of e to the minus alpha t minus e to the minus beta t by t. You can write it in this way. So that is equal to 0 to infinity. 0 to infinity, Laplace transform of this function is equal to 0 to infinity, then 1 by t to the minus alpha t dt, then minus 0 to infinity 1 by t e to the minus beta t dt. So you can write this as this. You can write this as, let here 1 by ft, this is the function of ft, and e to the minus alpha t dt. Just compare this with the definition of the Laplace transform. In that case, Laplace transform of any function, that is ft, was integration 0 to infinity ft e to the minus pt dt. So comparing that, you can easily understand that p is equal to alpha here. p is equal to alpha here. So 1 by t to the minus alpha t dt, that can be written as the Laplace transform of 1 by t when p is equal to alpha. P is equal to alpha. I am just multiplying here by a constant, or you can write it into 1. So 1 by t to the minus alpha t dt, that is nothing but the Laplace transform of Laplace transform of 1 by t at p is equal to alpha. Okay. Okay, I have multiplied here by 1. So then minus, this is what? F function of t, this means function of ft, function of t, then e to the 1 as pt, p is in this case beta, and then dt. That is nothing but the Laplace transform of 1 by t at p is equal to beta. I have multiplied here by 1. So you know that the another formula was there, that is Laplace transform of 1 by x fx, that is equal to p to infinity fp dp. So this term and this terms are identical, similar term. So Laplace transform of 1 by t into 1 at p is equal to alpha can be written as, since p is equal to alpha, the limit should be alpha to infinity. Then here 1 by p dp, because you know that the Laplace transform of 1 is 1 by p, then dp. From this term you can write, since in this case p is equal to beta, so beta to infinity, and here is 1, Laplace transform of 1 is equal to 1 by p, and then dp. So that is equal to log p, since this will log p alpha to infinity, then minus log p beta to infinity. So that will provide you, just calculate this, simplify this, that will give you log beta by alpha. So this is the result. Now another one is there, find the Laplace transform of the function ft, which is defined as ft is equal to sin t for 0 less than pi less than t, and 0 when t greater than pi. So here the function given is ft is equal to ft is defined in this way. So for the function ft, the Laplace transform can be written as or defined as lft, that is equal to 0 to infinity e to the minus pt ft dt, and this can be written as 0 to pi e to the minus pt ft dt, then plus pi to infinity to the minus pt ft dt. You can separate this, divide these limits in this way. Now according to the definition, the first part, that is 0 to pi, in the 0 to pi the value of ft was sin t, so that is written as this e to the minus pt is there, then sin t dt. After that plus pi to infinity, you know that in this case, since the function is defined as ft is equal to 0, so in this limit ft has the value 0, so 0 into this, so that is equal to, this term will give you 0 result, null. So Laplace transform of ft is equal to 0 to pi, the first term will be only there, e to the minus pt sin t dt, that is equal to, I say. So now I is equal to 0 to pi e to the minus pt sin t dt, that is equal to, you can just evaluate this or integrate this by using the method of integration by parts. So in that case e to the power minus pt should be taken as constant first, so that is here. Then just integrate this, integration of sin t, that will give you minus cos t, then 0 to pi, then minus will appear here, 0 to pi integration will be there, integrate, then differentiate this term, that is minus p e to the minus pt, then integrate this term sin t, that is minus cos t dt. So that is equal to e to the power, from here if you use the value pi, the value t as pi, the upper limit, then this will give you e to the minus p pi, then cos pi means minus 1, that is e to the minus p pi with a plus sign. After that, if you use 0, t as 0, so that this term will give you 1, and this term will give you 1. So since it is the lower limit, so this minus, and for the lower limit another 9 minus negative sign will come, then that will give you positive sign, that is plus 1. So using these limits, you have e to the minus p pi plus 1, then minus this p is taken here, because 1 2 3 negative signs are there, so negative sign is there finally. So this p is here, 0 to pi e to the minus pt cos t dt. Now these two terms are here, then minus p, then just integrate this using the method of integration by parts. So that is here, first p should be taken as constant, e to the minus pt should be taken as constant, this p is here, e to the 1 as pt, then integration of cos t is equal to sin t, 0 to pi, the limits are. Then minus, and this p is here, and differentiation of e to the 1 as pt. So this minus and the negative sign that will arise due to the formula of integration by parts. So there will be two negative sign, and differentiation of this will provide another negative sign. So three negative sign will give you finally negative sign. So that is minus, and this p and differentiation of this will give another p. So that is p square. Then 0 to pi e to the 1 as pt, and integration of this will give you sin t dt. So from here I is equal to 1 as p pi, then plus 1, and using the limit pi here, see here sin pi, that this term will give you 0 for pi, and for 0 this term also will provide you 0, because that is, it is nothing but 0. So that is here 0, then minus p square is here, and this is nothing but, see here, this is nothing but I. So that is, I have written here I, p square I. So just take this term in the left hand side. So I is taken as common term, then p square plus 1, that is equal to 1 as p pi plus 1, or I is equal to 1 plus e to the 1 as p pi by p square plus 1. So the Laplace transform of the function that is defined in our problem, in our present problem, that is this is equal to 1 plus e to the 1 as p pi by p square plus 1. Now another problem is here, find the Laplace transform of 1 plus cos 2x. So the given function is 1 plus cos 2x. So the Laplace transform of the function fx is, you know that that is Lfx, that is equal to L of 1 plus cos 2x. So now L plus 1, L Laplace transform of 1 plus cos 2x, that is equal to 0 to infinity e to the power minus px, then 1 plus e to the power 2. You can write cos 2x as, you can write cos 2x as e to the power 2ix plus e to the power minus 2ix by 2. You can write this. Cos 2x can be written in this way, e to the power 2ix plus e to the power minus 2ix by 2. Then dx is there. That is, then after that this half is taken here, and if this taken as common term, then this should multiply this here. So that is half 0 to infinity, then 2 e to the power minus px from this term, and after that you just this and this term will give you e to the power minus p plus 2i, then x plus this term and this term will give you minus p minus 2i into x dx. Just simplification, nothing is difficult here. Just only simplification is carried out here. So half is here, and then integration of this will give you 2. If this 2 is here, then e to the minus px by minus p. Then plus is taken, this plus is here. So integration of this term will give you minus p plus 2i into x by minus p plus 2i. Okay, then the integration of this will give you plus is, this plus sign is here, e to the power minus p minus 2i into x by minus p minus 2i. The limits are 0 to infinity. So that is equal to half. And now from here, if you use infinity as the limit of, for the higher limit infinity, this term, all terms will give you null result. Only the lower limits will be there. So for the lower limits, this negative sign will be appear, and since there is another negative sign, so that will give you positive sign, and this will be provided 2 by p. Okay, and for this term, for the lower limit, negative sign will appear here. After that, for 0, 1 by minus p plus 2i, and from here minus 1 by minus p minus 2i. Okay, just simplification will be carried out here. Half, then 2 by p is here, then minus sign is, minus is taken here, so minus plus 1 by, then p minus 2i, and here this negative sign taken here, so plus with this negative sign and this negative sign will give you plus sign 1 by p plus 2. You can write these as well in this way. So that is equal to half, then 2 by p. So simplify it. It is the denominator will be p square minus 2i whole square. That means 4i square. So that will give you, since I square is minus 1, so p square plus 4, and here p plus 2i, and the next term in this case is p minus 2i. 2i will cancel each other. So that is equal to half. This half is here, and from here, this here is 2. Here there is a 2, and in this case 2p will be there. So 2 is taken as common term. So from here 1 by p, and from here p by p square plus 4. So 2 will cancel, and finally this 2 term will give you p into p square plus 4, and from here p square plus 4 plus p square, that is 2p square plus 4 by p square 4. So this is the Laplace transform of the function, that is 1 plus cos 2x. That is also written here. The another problem one is here. So find the Laplace transform of the following functions: e to the power minus 3x or 2 cos 5x minus 3 sin 5x, and another one is e to the 4x sin 2x cos x. So the Laplace transform of e to the power minus 3x for the first function 2 cos 5x minus 3 sin 5x. We are here to find out the Laplace transform of this function. So first, that is written here. Laplace transform of e to the power minus 3x 2 cos 5x minus 3 sin 5x, that is equal to, that can be written as 2 Laplace transform of these into this, that means e to the power minus 3x cos 5x, then minus 3 Laplace transform of e to the power minus 3x sin 5x, that is here. So now you know that Laplace transform of sin ax is equal to a by p square plus a square. So the Laplace transform of this sin 5x, that is equal to, in this case a is equal to 5, so 5 by p square plus 5 square with a is equal to a. So now Laplace transform of e to the power minus 3x sin 5x, that is it has the form like e to the power minus e to the power ax, e to the power ax fx. Laplace transform of e to the power x ax fx. So from the first shifting property, you know that Laplace transform of e to the power ax fx, that is equal to f of p minus k, where fp is the Laplace transform of this function fx. In our present case, the function fx is sin 5x, whose Laplace transform is this 5 by p square plus 5 square. And this term, now this term and this term, comparing these two, you can easily understand that a is equal to minus 3. So in this expression, that is Laplace transform of sin 5x, p should be replaced by p or minus of minus p, that means p plus 3. So that is done here. That means Laplace transform e to the minus 3x sin 5x, that is this 5 is here, and then p is replaced, should be replaced by p plus 3, so p plus 3 whole square, then 5 square. Again, the Laplace transform of cos 5x, you know. So cos ax, you know the value of Laplace transform of cos ax is p by p square plus a square. So in this case, since a is equal to 5, so Laplace transform of cos 5x is equal to p by p square plus 5 square. Again, in this case, since you have to calculate or compute Laplace transform e to the minus 3x plus 5x, similar reason is here. You have to employ the first shifting property. That means in this case, p should be replaced by p plus 3. So that is here, p is replaced by p plus 3, so p plus p, and here p plus 3 whole square till 5 square. So now I have to substitute the value of these and these. Then you can have the value Laplace transform e to the minus 3x 2 cos 5x minus 3 sin 5x, that is equal to, first you have to write, since you know that you have already obtained this expression. So 2 into Laplace transform of these, that means 2 into this value, that is p plus 3 by p plus 3 whole square plus 5 square, and then minus 3 into this, that means 3 into this, means 3 into 5 by p plus 3 whole square plus 5 square. Just simplify this. This is the same term, so the denominator will be p plus 3 whole square, then 5 square, and here will be 2p plus 6, and then 3 5s are 15, minus 15. And just write it in, it can be written as p square plus 6p, then 9, then 25 is here. So from here 2p minus 9, and here from here p square 6p plus 3p. So this is the result of the Laplace transform of the given function. That means e to the minus 3x cos 2x 5x minus 3 sin 5x. This is the result. Now another one is Laplace transform of e to the power 4x sin 2x cos x. We have to calculate this, and so Laplace transform of this function is this L of e to the 4x sin 2x cos x. Now sin 2x cos x can be written as half of 2 sin 2x cos 2x. You can write this. And you know that in this case, see here, you can write this term further as sine 3x plus sine x, because sine c plus sine d is equal to 2 sine c plus d by 2, then cos c minus d by 2. So this can be further written as sine 3x plus sine x with this half here. So now the Laplace transform of sine 2x cos x, that is equal to this half is here, Laplace transform of sine 3x, then plus half, this half is here, Laplace transform of sine x from here. So that is equal to half. You know that Laplace transform sine x is equal to a by p square plus a square. In this case, a is equal to, for the first case, a is equal to 3. So 3 by p square plus 3 square, that means 9. Then half is here, and in this case, your a is 1. So half 1 by p square plus 1. And that is half is here, 3 by p square plus 9 plus 1 by p square plus 1. You have now to, this is the Laplace transform of this. Now the Laplace transform e to the 4x sine 2x cos x. This is the function fx, and e to the 4x here. So you have to use the first shifting property, that is L of e to the x fx, that is f of p minus a. So in this case, your a is 4. So p should be replaced by p minus 4 in the expression, in this expression. So this is equal to half from here, 3 by p minus 4 square plus 9. Then plus 1 by p minus 4 whole square plus 1. You can you can write, you can leave it here, or if you wish, you can simplify this. So, but it is not need to simplify, you can leave it here. So this is the end of this class.